Hi my dear students, very good morning. Now today we will going to proceed lesson number 5, continuity and differentiability. So in that my dear students, we will going to see exercise 5.1. Prove that the function f of x is equal to 5x minus 3 is continuous. So my dear student, before proceeding this exercise 5.1, first let us try to understand what is the meaning of continuity and differentiability. My dear students, if generally I will talk about continuity, then continuous means if we can freely draw a curve without lifting a pen, then the given curve is called continuous. Now, so I hope so everybody understood my dear students. When you can draw freely curve without lifting the pen, then that curve is called continuous. But if you are lifting the pen, there is breaking happen in the given curve. Breaking point we are getting, so there is a breaking of the curve. That breaking of the curve is called discontinuous. So always keep in mind my dear students, when really you can draw the curve without lifting the pen, then that curve is called continuous. But if you are lifting the pen, then what will happen? There will be breaking of the curve will happen, and that breaking point is called discontinuous. So this is the generally meaning of the continuous. Now how we can define mathematically, how we can take mathematical approach about continuous, let it see. My dear students, a function is said to be continuous if its limit is exist. A function is continuous if and only if its limit is exist. A function will be continuous if limit is exist. If limit exists, the function will continue. Then the function will continuous. So how we can give mathematical definition? So let's see my dear students. So suppose we are taking one example of the limit x tend to a, f of x is equal to f of a. So if limit exists, then the function is continuous. Therefore it is very important, we must know what we mean by limit. So let's define the limit. What is the limit? If I will talk in topological space, if there is a sphere with center f of a and radius epsilon contain other sphere with center a and radius del, then it's said to be limit is exist. So always keep in mind my dear students, whenever center with f of a, radius epsilon contain domain approach into that sphere, then always limit exists. Okay, so how to give definition of this limit? So this is a topic in topological space. I have defined what mean by limit. So what mean by limit? Whenever a sphere which contain center f of a with radius epsilon, where epsilon is very small, infinitely small value, very closest to the 0, and del is also very small, infinitely small, very closest to 0, but del is less than equal to epsilon. I means the radius of this sphere always less than equal to the epsilon, my dear students. Okay, so now how we can write in another way definition? If x minus a will less than del implies mod of f of x minus f of a less than epsilon, where del and epsilon, these are arbitrary infinitely small value very closest to 0, and del is less than equal to epsilon. So this definition in topological space I have given like this: with center f of a and radius epsilon, when it will contain this domain approach with center a and radius del into this sphere, then it's said to limit is exist. If this sphere will lies outside with center a and radius del, then limit will not exist, my dear students. So always keep in mind, if I will talk in topological space, when center in domain approach